Okay, I'm going to introduce our last presenter in this room, Anil Kumar, who is our technical product manager.
Hello, everyone. Thanks again. So this presentation is very more on the operational side. So keeping your Couchbase cluster healthy, right? So I know most of you, it was a whole day of events. So this, I'll try to keep it more interactive in the sense, I have a lot of slides where we have animations and everything. So make it, it will be good for, you will be attentive here. So today's diagnostics, we'll be looking at what does a healthy Couchbase cluster looks like. And also we'll look at what an unhealthy Couchbase cluster look like. And how to use the Couchbase monitoring system. We have a huge monitoring system, one of the best, I would say. And I'll show you how to use the Couchbase monitoring system, what are the key system metrics to look for, and also the Couchbase health check tool which we provide. So how to use the health check tool for keeping your cluster healthy. So with that, let's get started. So what does a healthy cluster looks like, right? So basically, cluster is in a good health when it's running without any issues, and it's performing at the sufficient satisfactory performance, and also it has enough room for capacity for unknown loads, right? So if that's the case, in case of Couchbase cluster, some of the things we should be looking at to make sure that the Couchbase cluster is healthy is, the first thing I would say is the active vBuckets. So we have this monitoring system, and I would show you later in the slides how the monitoring system looks like. So one of the things which we look for is like the active vBuckets. So if you have attended the previous slides, previous sessions, so you might have known that we create 1024 vBuckets, like 1024 shards in the Couchbase server, right? So at any one point of time, the active vBucket count should be always 1024. If some of the partitions, some of the active vBuckets are missing, that means that some of the data partitions are not accessible. The clients are not able to reach them. So there's a particular stat in vBucket resource in our admin UI. So it will show you the count of the vBucket count, active vBucket count. And if you have multiple servers, like let's say that you have 10 servers, this 1024 will be spread across all those 10 servers. So it will show you on each server how many active vBuckets are there, and if some of the partitions are missing on one of the servers, it will show up on our UI. So next thing is, so this is important because this guarantees you that your partitions are active, and none of your partitions are missing, right? So similarly, we have a replica vBucket count, which is also useful because if one of the server goes down, then we do the failover. At that point, your replica vBuckets will be promoted to active. So you have to make sure that your replica vBuckets are also, in terms of count, it will be 1024 into number of replicas you have configured. So in case, let's say that you have configured 2 replicas for your cluster. So in that case, the count will be 1024 into 2, that is 2048. So at any point, your active and your replica vBucket count should be 1024, and that will be multiple of number of replicas configured. So the next important thing which we look for, so this basically I have kind of, there's a ops training which goes on for like 2 days. I have talked to the solution architects, and Alex Ma and Perry are here. So they kind of gave some information. So I gathered all this information and put together the slides. So this, in a high level, these are some important slides. Some of these important stats we look for. So the third one is the cache miss ratio, and the disk reads per second across all the servers should be equal to 0. What that means is, like, if you have an application requirement that you want a low latency sub-millisecond response time, and in that case, if the cache miss ratio is higher or the disk reads per second is higher, that means that you are reading some, if any read or write operation, you're doing it from the disk. So you're fetching it from the disk, which will have some latency. So you won't be able to achieve your sub-millisecond response time. So you have to make sure that, if you look at your UI, you would see that cache miss ratio and the disk reads per second will be 0. That guarantees that all the active set is in memory so that you get a sub-millisecond response time. So next thing is the items in tab queue and disk queue. So these both are very important. So as I mentioned, you can configure replicas within a cluster, right? So if you have replicas configured in a cluster, So as soon as the data comes into one server, we do a memory-to-memory replication. So that is using the tab queue. So if there are a lot of items in the tab queue, which means that items are not getting replicated to the another server, which is a problem because in case if the server goes down, then you will lose the durability. Similarly, if the disk queue is full, that means that you're not persisting the data to the disk faster. So in case if you have not configured the replicas, and if the disk queue is full, that means that there is a chance of data loss, right? So in healthy case, you will see that this number will be much lower. So in case of tab queue and disk queue, it will be much lower. So these are some of the things which indicates clearly that your cluster is running healthy and nothing to worry about. Sorry? So TAP is a protocol we use for, it's an internal protocol for transferring the data, to keeping the data synced between the servers. So now that we looked at healthy cluster, now let's look at some of the what the symptoms of unhealthy clusters. So when I say symptoms of unhealthy clusters, there are a lot of symptoms of unhealthy clusters. So for example, in terms of Couchbase server, the symptoms are if the memory used is equal to the high water mark. So I don't know, most of you may be familiar. The high water mark is for the active items. In the sense, we have active items as well as the replica items, right? So the high water mark is for the active items. If it's equal to the memory used, that means there is no more space for adding new data to the memory. So if any new data comes in, we have to evict some older data from the memory. So that way we can make room for the new data. So eviction also, in case of Couchbase, we use an algorithm called not recently used algorithm for evicting the old items. But even then, if there is any request comes for any particular item which is not found in the memory, then it has to do a disk fetch. So there will be a latency. So you have to make sure that your memory used is not equal to the high watermark. That means that you still have a room for growing in case of RAM. The second thing is in case of, so if there is a sustained write rate so if your drain rate is much lower than the fill rate. So if you are filling in much faster than actually you can drain to the disk, that means the disk queue is getting bigger and bigger. Since the disk queue is going full, it will be like growing faster. In that case, you're not persisting the data much to the disk. In that case, there will be a lot of items still in the queue which needs to be persisted to the disk. So the indication here is like if you see if there's a couple of slides, it will show you that there's a fill rate as well as the drain rate. So fill rate is much higher than the drain rate. In this case, it's not that really higher. But if it's substantially higher, that is an indication that your disk queue is going to be full and there'll be a problem. Disk queue size. We have another stat for the disk queue also. So temp out of memory, so there's another stat for temp out of memory, which means that your memory usage is at or above the 90% of your bucket memory quota. So when you create a new bucket, you get to choose how much memory you want to allocate for that bucket. So if you have allocated a memory for that bucket, and you start getting the temp out of memory, this is a good indication that you don't have any more RAM space for that particular bucket. So you might have to reconfigure in the sense you have to add more, in the sense you have to allocate more memory to that particular bucket. So finally, the disk reads per second and cache miss ratio growing at hundreds of thousands. That means that there's absolutely no space in memory. So that's why every read or write request is going to the disk for the read and write access. So in that case, you will see that disk reads per second or the cache miss ratio will be really high, and all the operations, the read-write operations are happening from the disk. Okay. So moving on to the what Couchbase monitoring system is and how you can use it for keeping your cluster healthy. So some of the things we provide in Couchbase monitoring system, as I mentioned, it's one of the best monitoring system compared to any other database vendors. So we have a real-time traffic graphs, which is like we collect stats from entire cluster. So basically, from the entire cluster, from all the servers, we collect the stats. They are almost real-time, and I'll show you in the UI how will they look like. So on all the stats are REST API accessible. What that means is you can, if you want to extend your current existing monitoring system to capture the stats collected from the Couchbase, you can still do that. So if you are building a custom app, or if you have already a custom monitoring system, you can use our REST APIs to incorporate the stats from Couchbase. Also, the stats collected are on a different dimensions. We collected the stats on a per bucket basis, on a per node basis, and also we aggregate them. So we aggregate, for example, if you're looking for a stat on a disk size, and so we aggregate the stat information on a year, month, day basis, so that you can basically project and see what was the disk size at the beginning of the year and how the progression has happened. So you can make a decision on the capacity planning, basically. So finally, so one other thing we do is we also have stats for intra-cluster and as well as cross-data center replication. So we can see what's the replication lag within the cluster as well as replication lag on the cross-data center replication. So moving on, let me walk you through the Couchbase admin UI. I didn't trust the demo, so I basically took the screenshots of all the UI, and also it will give me a chance to explain them in detail. So this is so once you install the Couchbase server on a server and go to localhost 8091 port, so you will see the admin UI, and this is the initial screen, right? So we have a cluster overview page. So so that's the first tab. In this, we have three sections. We have cluster, buckets, and servers. In the cluster, we see this RAM's overview is completely on the entire cluster. So we have total allocated RAM, and the in-use and free available RAM. So this information on the RAM. Then we have a disk overview, which gives you about the usable free space, in-use, and all a complete snapshot of these two stats. On the buckets, moved on. So on the buckets, it gives you a snapshot of like how many active buckets are in the cluster, and also it has two things, which is like operations per second, which is across all the buckets, and again we have disk fetches per second, which is again across all the buckets. And third one is the servers, which gives you a snapshot of how many servers are installed in the Couchbase cluster, and how many of them are active, how many of them are failed over, or how many of them are in a pending state. So it gives you like any idea. It's scrollable down, so it gives you an idea like how many of them are active, failed, or in a pending state. Right? So one important thing to watch here is we have. So you see in the top there's a rebalance by nodes. So any significant events such as rebalance operations or compaction, those operations, you'll see a small progress indicator on the top, which indicates that the rebalance operation is happening and on this two particular buckets. So it gives you an idea. And we do have a detailed information, like granular information on how many keys are getting moved and which active partition is moving, and also in the server page. But on this cluster overview page, any significant event, you'll see a small progress indicator. Yeah. Oh, so the read-write threads. You're talking about multi-read-write threads. That's for the disk storage. In the sense, like if you want to persist the data much faster to the disk, that's the separate threads, memcache threads. This is rebalance is on the NS server, the cluster manager threads. Sorry. No, so all the operations in Couchbase are online. So which means that at any one point, like let's say that you have multiple servers you want to add to the cluster, and so when you start the rebalance operation, some partition from the other servers will start moving. Unless all the operation is complete, the rebalance operation is complete for that particular partition, the atomic switchover will happen. Only then the traffic will start moving to the new partitions. Till that point, the client will be still talking to the old servers. So in terms of application, they will never see, like there will be no change. So it will keep moving, and when the switchover happens, it starts talking to the new servers. So as I said, so if you're adding more servers, there's a replication. We set up the replication queue, right? So we set up a new replication to the new servers. Some of the partitions has to be moved to the new servers, right? So we covered in the earlier in presentation in the morning session. So which demonstrated we had a demo which showed like the ops per second from the like on the cluster. And we added a new servers. The ops per second never dropped below, so it kept on the same sequence. So only when the operation complete, so we'll see that the operation per seconds will come down because we have more capacity now. So next thing we are looking at is the server nodes page. So the server nodes page it lists on all the active servers in your cluster, and also. If any of the server is in the failover mode or in a pending state, they will appear up here. So one important thing to watch here is the, so I went ahead. So if you want to expand, if you expand that particular server, it will show up some more details about the server. I have another slide talking about that. And so the important thing about here is like, if you add multiple servers, so one another thing, advantage of, when you want to increase the capacity, you can add multiple servers at the same time. So you don't have to move the data multiple times. So you can add the servers. They will be in a pending state, which means that they are part of the cluster, but they are not taking any traffic. In the sense, the partitions are still not active. So when you can add them in the pending state. When you hit the rebalance, the partitions will start moving, but even then they still will be in the warm-up or in the pending state. Only when the operation gets complete, the traffic will start moving to the new servers. So you would ideally, when you add new servers, you'll see it in the pending state. There'll be a mark which says how many servers are in the pending state. But when you hit the rebalance, that will go away, and then the rebalance progress indicator will start. So on the side, this section showing up is all the rebalance operation. It shows that how much progress is made on the rebalance. Okay, so I mentioned in the previous slide that when you expand the server, it gives you some additional information. So the additional information here is like, for example, in this case, the server name, the IP address, OS, the operating system, which version of Couchbase server is running. And also, if any rebalance operation is happening, we give some granular details about which bucket and how many number of what keys has to be transferred, and what's the estimate number of keys that already transferred, which active partition, which replica partitions. So any administrator who is doing the rebalance operation, now they get a detail about which partition from which server is getting moved to which other server. So they get more granular details. Okay. Also, additionally, we have the memory information and also the disk storage information on this particular server. So when you go to a data buckets tab and click on the bucket, so it brings you to this monitoring system. So this is our monitoring system where we collect. So this is our monitoring system. It's again, I told at the beginning that we have a different dimensions to look for. So we can look at on a per bucket basis on one server or on all the servers on all the entire cluster. And also we collect around 120 plus stats from the entire cluster. So I talked about we aggregate the stats data on the time scale. So we have it on the month, minute, hour, day, week, month, year. So if you like move the scroller, so it will show up in the different times in the time scale. So no, the cluster. So we have. So if you know the Couchbase architecture, we have two parts into it, right? So we have a data manager part and the cluster manager. The cluster manager handles all the cluster level activities. So it's a different process than the data manager. So it won't really affect any data related operations. Even if the cluster manager process is like dead, it doesn't really affect the data manager process. So if you click on that particular Eclipse, it will show the same stat on all the servers. So if you have 4 servers in the cluster, that particular stat will show up on all the 4 servers. So you can see the sets per second. Right now you're seeing it on an entire cluster. But when you click on the Eclipse, it will show up on all the 4 servers how many sets per seconds are happening. Also, we provide a short description of the stat, which explains what the stat is, and how are we calculating this particular stat. So we have some internal stats, like for example, EP engine or NS server stats, so that stats will appear up here. So if you are not sure which stats to look for, and also you can usually click on it, look at the tooltip, it explains what stat is and how it will be useful for. Okay. And also on the top, you can see there is a compaction background process which is running, the compaction job, which as I mentioned, any small, those kind of events will be appearing on the top. So finally, we have a logging system also. So we log all the significant events on this tab. So we see that all the events are here. So administrator can come back and look at any events which had happened on the cluster. So we have all the events here. We have the timestamp and which server it happens. So now that we looked at the monitoring system, I'll go a little deeper into. I'll explain some of the very important sections in the monitoring system. So for example, we have this vBucket resources. This is one of the section within that 120 stats we collect. So the vBucket resource is basically useful for, basically gives you information about all the, about the individual data partitions. So we have the active partitions, replica partitions, and some of them in the pending partitions. And also we have this tab. So the way the table is displayed is we have the active state, so which is basically all the active partitions here, number of active vBuckets, number of items in the active vBuckets, the resident ratio. Similarly, we have the replica state, pending state, and also the total across all the stats. Right? I'll pick a couple of the important stats to explain here. So as I mentioned, the vBucket resource will have vBucket count of vBucket count, which is the number of vBuckets. So active. So for example, if in case of active, it will show the number of active vBucket counts. In case of replica, it will show the replica vBucket counts. The next important thing which I'll look for is the resident ratio. So what actually the resident ratio means is, by default, we have a resident ratio of 80-20, which is 80% of active items and 20% of replica items. So in case, so for example, within this resident ratio, we have this high watermark and again low watermark, right? So the resident ratio is the percentage of items within the vBucket that are resident in RAM. So in case, so for example, if you want to make sure that in case if the server goes down, you want to have the replica items also in the RAM, then you can change this resident ratio to like maybe 40, 60, 70, 30, or that kind of thing. So in case if the server is down, you bring up the another server, the replica items will be also in the memory. So we have internal settings. You can use that settings to change it. So next important thing we look at is the disk queue. So basically the disk queue is, again, this is one of the section in the whole monitoring system. The reason I picked them is because the disk queue gives you an indication of whether you're persisting to the disk much faster. I mean, in instance, like when you look at the fill rate and the drain rate, the incoming is much faster than the draining to the disk. So if you see that the fill rate is higher, very much higher than, substantially higher than the drain rate, that is a good indication that your disk size is growing much faster, right? So again, we have 3 states: active state, replica, pending, and the total. And let me show you the 2 items: the fill rate and the drain rate. So it's important to watch for the fill rate and the drain rate. These are that indicates whether your cluster is doing healthy or not healthy. So I mentioned about we collect also the stats for the intra-cluster application and the cross-data center application. So this is a cross-data center application, right? So we have, when you set up a replication between one cluster and another cluster, we'll start collecting the stats for incoming rate, outgoing rate, how many mutations are pending to be replicated to the other cluster, and you can see some of them here. So what we have around 15 stats which we collect for incoming and outgoing replications. These are again important stats. If you have a replication lag, you can come and take a look at a particular, for example, outbound XDCR mutation, which indicates that there are huge number of items which are in the queue that needs to be replicated to the other cluster. Yes, definitely. So we support both the unidirectional application, bidirectional application. So when I say bidirectional, it's basically if you have a cluster A and cluster B, so you will have a unidirectional application, and from the cluster B, if you set up another unidirectional application, we have this bidirectional, and we support the conflict resolution between the clusters. So if the same key gets updated on the cluster, then we pick the winner. We have the mechanism of conflict resolution. So we have basically active state. So both the cluster can be rewrite, and they can take a rewrite. So what are the key system metrics to look for or to watch for, right? So here I'll explain about a symptom, and then I'll explain which key metrics to look for, right? So if the symptom is working set doesn't fit in RAM, so what are the key metrics to look for? So we usually look for cache miss ratio plus the disk reads per second. So that indicates that there's no more space in the RAM, and all the read-write operations are happening from the disk. So you need to look for cache miss ratio and the disk reads per second. The next symptom is like disk I/O not keeping up, right? So it's not able to persist much faster to the disk. So in that case, you'll see that disk write queue size will be huge. So that's the indicator that the disk I/O is not keeping up. So it's the internal replication lag. So I explained about within the cluster we have intra-cluster replication, which is from memory to memory. So and the key metrics to look for is the tap queue size, which is the protocol we use for replicating the data from one server to the another server. If the tap queue size is huge, that indicates that a lot of items are still in the source and it's not replicated to the destination. So that's the stat you should be looking for. The XDCR log, so that's if there is a huge latency between the source cluster and the destination cluster. So in that case, if you want to find out what's the lag, you can look at the outbound XDCR mutations per second, which indicates that this is on the source cluster. You'll see that there are a lot of items, which are a lot of mutations, which are still in the queue and not yet replicated to the destination cluster. Okay. So moving to the last session, which is last part of it, is like what health check tool we provide, right? So we have we provide a CBHealthChecker Tool, which is now part of the product, which gets shipped as part of the software. So what this CBHealthChecker Tool provides is, when you run this CBHealthChecker Tool, it goes and collects a lot of information from the cluster and analyzes it and generates a report. So this report will have basically multiple things, which is like first thing is alerts. If there is any immediate action which you need to take, so it will alert to the user saying that there's this particular issue and you need to take this action. So it gives you all alerts in the top. And then we have the summary of the cluster. Basically, it gives you a summary of the whole cluster. When I say cluster, it gives you details about the per bucket, on per buckets or on the per nodes. And also we have in the 2.2 release that got shipped today. So we have added some enhancement to the CBHealthChecker tool. Now for each server we have sizing related information, and some of the sizing information we put them on a chart, so it shows you a trend of what's happening for this particular stat, right? So I'll show you a sample report. And also, finally, we do have a warning which indicates give you an early indication something might be going wrong, so you should take some action kind of thing. So we have some warnings, we have alerts, and summary, like snapshot of the health of your system. So we have good documentation on the CBHealthChecker tool. That's the link there. The CBHealthChecker tool runs on all the platform, and the usage is very simple. You need to provide the username, password, which bucket you want to run. If you don't give the bucket name, it runs for all the buckets. And also you can give the scale. If we want to run for year, day, month, or like minute. I'll show you. So this is one of the sample healthy report. So the report looks like, so we have the time scale, okay, here. So we have different categories to jump here. So if you want to if you are interested only to look for errors, then you can click on the errors. It shows only the error related to the cluster. If you are interested in the cluster overview, which is like all the nodes, all these the buckets, you can click on that category. So basically, you can jump off to that particular categories. Also, we have different time periods. So if you want to see it on a minute basis or a month or year, you can change the settings there. And so if you expand this sizing stuff, so I was mentioning before, now we added a new enhancement, which is like for some of the sizing related stuff, we put them on a chart. So if you pick, for example, month, and then click on the sizing, it will show up that particular stats on the chart. Yeah, so the way the CBHealthChecker does is like it basically, as I mentioned, it collects a lot of information. We have rules and like thresholds. Based on that, it calculates, analyzes, and puts together the report. So you can see if there is any issues, it will highlight here. So I have a report which is for the unhealthy report, and the cluster report. Here is an indication. It shows that the bucket 1 and bucket 2, it needs an immediate action. Looks like some active partitions are missing. So it gives you an alert on the top. Thanks, everyone.